Today, I'm excited to announce a new release from the Microsoft Research AI Frontiers Lab, MagenticLight. MagenticLight is the next generation of Magentic-UI. It works across both the browser and your local file system in a single workflow, keeping you in the driver's seat at every step. Along with MagenticLight, we're also releasing the two models powering it. MagenticLight is a result of deep collaboration across AI frontiers, spanning model development, agentic systems, agentic harnesses, and UX. Together, the team has created an end-to-end innovation throughout the agentic stack. We'll now hear from my amazing colleagues, Waili, Harkarat, and Hussain, who will walk you through MagenticLight and the models and demo it live.
Hi, I'm Waili.
I'm Hussain. And I'm Harkirat. And we are all members of AI Frontiers, a boutique lab inside Microsoft Research. And for the past few months, we've been working closely together to reimagine what an agentic application can look like, one that's efficient, capable, and useful for getting work done.
To do that, we had to work on the full stack, rethinking everything from how we generate training data, how we design the models, how the harness orchestrates it all, and to the user experience that makes the whole thing feel like genuine collaboration.
What really moved the needle was going beyond standard benchmarks. We started with hero use cases, real everyday tasks that people care about. We built our own evals around them, and we used this signal to drive a flywheel of iterative improvements across the whole stack. And the result today is 3 joint releases. First is MagenticLight, our experience where you can get a real feel of these small language models to get real work done. Second is our computer use agent model, Fara 1.59b, a state-of-the-art model for models at its own size class. And last but not least, Agentic Orchestrator, a model capable of reasoning, delegation, coding that brings the whole experience all together. And now Waili is going to show us how MagenticLight works.
Let's dive into MagenticLight. You may have heard of Magentic-UI, the agentic application we released last year that set the foundation for this work. With MagenticLight, we have reworked the agent harness to run efficiently on small language models, making it faster, more lightweight, and no longer reliant on frontier-scale models. We also refreshed the UX design based on community feedback, making it easier and more natural to work with. MagenticLight works across both the browser and your local file system to help you get real work done, whether that's filling out online forms, making appointments on your behalf, managing files on your desktop, or generating simple code. Let's see it in action. I can give MagenticLight access to a folder on my computer. Here, I'm giving the notes from the last Microsoft Build conference. I want the agent to search for what has changed and create an update doc to help me prepare for the next conference. It has successfully accessed my notes and created to-dos. Next, it opened a web browser and started to gather the information I need. MagenticLight has access to its own browser running in a virtual machine. This helps minimize the risk of data leakage while allowing Fara, our browser use model, to operate fast in the browser. Fara performs well at long-running tasks. It looks like Fara has gathered enough info and the orchestrator has created a document. Let's check it out. MagenticLight did the job. It included updates on all key sections. Next, I'd like to email this document to my colleague. I'll let MagenticLight do this for me. I can keep working on other things, and MagenticLight will notify me when my attention is needed. In this case, it needs my help to log into my email account. I'm taking control of the browser to log in. Once unblocked, the agent is composing the email and can send it off once it finishes. Now that you've seen it in action, let's take a closer look at the models powering MagenticLight, small models that punch above their weight. Next, Harkirat will introduce Magentic Orchestrator. Off to you, Harkirat.
Thanks, Willie. So if MagenticLight is the app that you interact with and Fara drives the browser, then Magentic Orchestrator is the brain that ties it all together. It is the planner, the coder, and the delegator all in one model. Its job is to take a messy request, like the one shown here, book me a dentist appointment Tuesday afternoon and add it to my calendar, and convert it into a concrete plan. So the orchestrator figures out the steps, picks the right tool or subagent for each step, writes code when code is the right answer, and recovers when something breaks mid-task. What's interesting is that the recipe is very simple. Orchestration is usually where people reach out for the biggest model that they can get. The reasoning is hard, the failure modes are expensive, but we wanted to show you that you can push all of this down into a small model without giving up on capability. The training itself is plain SFT. We don't use any fancy multi-stage pipeline. But the main unlock here is the data mix. We blend two different and complementary styles of data in the right ratio. Next, I'm going to talk about these types of data. The first style is standard tool calling. Clear, simple function tool calling. A request comes in, you pick the right tool, you call it with the right arguments, and you handle the response. For this, we built an in-house pipeline, which we call Vulkan, that generates this kind of data. The trick, which is shown on the left, is that every tool is a Python object, with its own arguments and return types right there in the class. On the right, those tools become nodes in a graph, and a single trajectory is an ordered path through that graph. As you can see, it starts with a search, then it goes to book, then it goes to your calendar, then it goes to your email. So the model here lands a realistic multi-turn composition, not just an isolated tool call. We then validate each path with rules and a sandbox, and mix it with other data that we created, including MCP trajectories, which are both public and our own synthetic trajectories. This is done to broaden the tool coverage. The second style of data is terminal data. What you are looking here at the top is an actual co-work style trajectory. A user requests, optimize all blog images to WebP. Then step by step, the agent thinks, takes an action in the terminal. For example, the action shown here is ls. The agent reads the results and decides what to do next. 10 steps like this for a single task. On the bottom, we show how we generate these trajectories at scale. A 4-stage pipeline. The first stage, we sample a scenario. In the second stage, we create a task and environment for that scenario. In the third stage, we run an agent to produce a full trajectory. And in the final stage, we collect the verified trajectories into the data mix. We pair the verified ones with code library task data for covering breadth. This matters because a lot of real requests don't have a clean tool. The right answer is 5 lines of Python. A model trained only on function calling tends to force everything into a tool call. But mixing both styles teaches it when to reach for which. The result competes with much larger general-purpose models, but it stays small enough to run next to Fara on your machine locally. And it's open weight, so you can plug it into your own harness too. With that, Hussein, over to you on Fara.
One of our goals in AI Frontiers is to train agentic models to complete computer use tasks. And our bet is that end-to-end synthetic data generation without any human interaction data is going to get us there. Last November, we made our first release with Fara 7b, a small but efficient agentic models that can complete computer use tasks at a level comparable to much larger models. And today, we're so excited to release Fara 1.5. This time, a family of computer use agent models across 3 scales, 4B, 9B, and 27B, all based on Qwen 3.5. Fara 1.5 is setting state-of-the-art results for model edit size. First, let's see how Fara works on the computer. Fara can handle web tasks that people actually want to complete, like form filling, booking, shopping, and repetitive annoying tasks. So consider a task like applying to the latest intern opening at MSR AI Frontiers. First, Fara starts by capturing a screenshot of the browser. The screenshots goes into the model's context alongside past screenshots, past actions, and the user messages. Given this context, Fara now will predict an action to perform on the browser. In this case, Fara decides to click on the career page. Given this action, we will execute it on the browser, and Fara will get to observe the result of this action and continue in its agentic loop. The action space of Fara consists of native manipulation actions on the computer like clicking on a set of coordinates, pressing keys on a keyboard, and tools for it to manage its own context, like memorizing facts so it can act across hundreds of steps. And finally, it also has a tool to ask the user for approval, permission, preferences when needed. On the online mind-to-web benchmark, which consists of 300 tasks covering 100 online URLs, Fara performs at a state-of-the-art level for models at its own size. So compared to its predecessor Fara 7b, Fara 1.59b almost doubles the performance, going from 35 to almost 65% on this benchmark. But we didn't train Fara just to do well on benchmarks. We trained it to perform well on tasks that people want to use it for. And the key recipe behind this is our scalable synthetic data engine, Fara Gen 2.0. The first ingredient is the environments. We trained Fara on a mix of live web domains across popular websites and complement those with synthetic domains. Synthetic domains mean synthetic websites that we've generated with the help of a coding agent in a tight debugging loop, so that we can expose our agent to scenarios that it doesn't see on the live web. For instance, sending an email, booking a flight, and so on that we just couldn't do on the live web. Given the environments and tasks, then we have a solver system consisting of a stronger teacher agent, in this case GPT 5.4, and a user simulator in a tight loop so that they can complete the task. Given the agent's trajectory, now we want to see, did we actually complete the task? And so here comes our last piece, the verifiers. We first judge for correctness. Did the agent perform the task correctly? And we use a set of rubrics that are LLM generated to judge this. The second verifier judges efficiency. How many steps did the agent complete, and did it find the most straightforward path to complete the task? And last but not least is user interaction. Did the agent make up information? Did it do irreversible actions without human approval? Did it not ask for clarifications when it needed to? Given all these ingredients, we can generate a lot of data on the fly, which we can then use to train our model using supervised fine-tuning. So our work with computer use agents doesn't stop with Fara 1.5. We have lots of plans to continue building in this line. First, by expanding with always-on capabilities to enable Fara 1.5 to monitor the live web, to act in additional environments like Windows and Linux, and use the terminal alongside visual manipulations to complete tasks more efficiently.